Hello and welcome to Codivate's Intro to Block-Based Programming in Scratch course. This is the final lesson, and today we're going to do a final project that encompasses everything we've learned so far. So, this final project is rock, paper, scissors. We're gonna create rock, paper, scissors in Scratch, where the computer and the player play against each other. So the game could look like this. We have two scores, and the user types the amount of games they want to play, and then they select rock, paper, or scissors. The computer then chooses rock, paper, or scissors randomly, and then we see who wins, and then add 1 to their points. And that's pretty much how the game works. Now, actually creating it is easier said than done. But it's not impossible to do. It's not that hard to do. We're about to do it right now. Basically, the easiest way to do this, and the best way to do this, is to break down the problem into discrete steps. So, when we're making rock, paper, scissors, what are the things that we want to do? Think to yourself. I think the things we want to do are 1. Ask the user for their option, either rock, paper, or scissors. 2. Ask the computer for their option, or create the computer's option at random. And then 3. Compare the two options. These are all separate steps. You can make them independently of each other. And then, at the end, compare the scores. And that pretty much is it. Here are the steps that I've chosen. They're asking the player their choice, asking the computer's choice, comparing the two, and adding to their respective scores. Then the fourth one is to add a repeatable way to do this. So just take 1, 2, and 3 and make them repeatable. And then step 5 is to just count who has the higher score at the very, very end. So let's jump into it. The first step is to write a program that asks the user for their option, rock, paper, or scissors, and then puts that in a variable. Now, the easiest way to do this is to use the ask block, because the ask block just asks the player for anything. So you can just ask them for rock, paper, or scissors. They will type their choice, and then you can use that answer block, that answer bubble, and just set a variable equal to it so that you don't lose it the next time you ask a question. And here's what it looks like. This is what the code looks like. We just ask the computer for rock, paper, scissors, and that's it. We type rock, it is now rock. If we type scissors, player choice is now scissors. So that's it. That's the first step done. The second step is to just, the harder step, I would say, is to create the computer's choice. Now, there are a few ways to do this, but I think the easiest way for now is to use the pick random number block. And that block is found on here. Pick random. Now, ask yourself, how many options are there in rock, paper, scissors? Well, 3. I just said all 3 options. So, we can use the numbers 1 through 3 to represent rock, paper, and scissors. So, if the number's 1, that means it's rock. If the number's 2, that means it's scissors. And if the number's 3, that means it's paper, for example. So, that is how we do it. So what we want to have at the end is a computer choice that is equal to rock, paper, or scissors. So after we get a random number, we can convert that number into a word with if statements. Basically, we can say if the number is 1, change it to rock. If the number is 2, change it to scissors. And if the number is 3, change it to paper. Just like that. And here you can find an example. just this. You set the computer's choice to a random number from 1 through 3. So right here, after the first block runs, computer choice is now some number. It's either 1, 2, or 3. And we have an if statement for each possible option. Now, assuming it's 1, this if statement will be true, and it will set it to rock. And since we set it to rock, rock is not 2 or 3, so it'll skip these two. If it's 2, it'll skip 1, and then when it gets to 2, it'll run it, set it to paper. Paper's not 3, so it skips the third one. And if it's 3, it'll skip the first two, and then 3 will be true, and then it will set it to scissors and go to the next bit. This is it. This is how you get the computer choice. Now we have the computer choice can either be rock here, it can be paper here, or it can be scissors, and they all have equal chances. It's exactly what we want. The next thing is arguably the hardest thing, which is to write a program that compares these two choices and awards points. Now, if you think about how we can do that, we need to think about what the rules of rock, paper, scissors are. We know that rock, paper, scissors is a game where if you pick rock and your opponent picks scissors, you get a point. If you pick rock and your opponent picks paper, you get a point. Yeah, they get a point, sorry. And if you pick rock and your opponent picks rock, neither of you get points. Now, if you think about it, there are how many options? How many options are there in rock, paper, scissors? Well, there are 3 options for player 1, and for each of those 3 options, player 2 can do 3 different options. So it can be rock, 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 scissor, rock, paper, scissor, rock, scissor, 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 paper, paper, rock, paper, scissor, paper, paper. Those are all of the options. Now, we don't actually need to make 9 different if statements. We can shrink it down just a little bit, and I'll show you how. So here, we have this. This is going to happen once, and then we're going to repeat it 3 times. It's going to look like this will be the entire code. And the way it works is the following. We check if the choices are the same. And if they are the same, then it's a tie and you're done with the whole thing. If they are not the same, then that means it's one of the following options. It's either the player picked rock and the computer picked either scissors or paper, the player picked scissors and the computer picked rock or paper, the player picked paper and the computer either picked scissors or rock. So in this first half, this is the first bit where if the player picked rock. So you have this if player choice is rock, then we know that the computer either picked scissors or paper, because if the computer had picked rock, we wouldn't have got here. So we check, is the computer scissors? If it is, well, we already know that the player choice is rock, and we know the computer choice is scissors, so who wins? The player, right? The player picked rock, the computer picked scissors. So we say that the player won for user friendliness, right? We want to say that the player won and not just increase their score without telling them. Then we add 1 to the score. Otherwise, the computer must have won, and we add 1 to the score. Now wait a minute. How do I know that the computer won if I didn't check that the computer picked paper? Well, I actually know for certain that the computer picked paper. And this is because we know it didn't pick rock. We know it didn't pick rock because the player picked rock, and if the computer had also picked rock, it would have been a tie. And it wasn't a tie. Then we also know it wasn't scissors, because if it was scissors, this block would have run and this block would have been skipped. So the only choice left is paper. And that is why we can assume that the computer picked paper here. Okay, so that is for just rock. Then you can re-implement this over here and just change the words. So instead of the ones for the player picking rock, we want the ones for when the player picked scissors, and then we want another one for when the player picked paper. Now, this might look like a lot of code, and that's because it kind of is. This is one of the downsides of having large if statements in your code. And there are ways to circumvent this and make your code smaller. Maybe only write this code once instead of 3 times. But that is something much more advanced than just simple scratch if statements. For now, we're just going to have to copy paste it 3 times. That is honestly the simplest thing for us to do. So, that's it. We now know how to compare the choices. We just have these 3 things. We put all 3 of these inside of the else after this. So it should look like this in the end. It should look like this. This one right here. Let me drag it further. I have the whole thing in front of me. So here, you check if it's a tie, and if it's not a tie, everything else is in the else. And you just check. Was the player picking rock? Do the rock thing. And that's it. Was the player picking scissors? Do the scissor thing. Was the player picking paper? Do the paper thing. And that's pretty much it. So, that was the hardest bit. It's mainly just tedious. You have to basically check through all the options. The next bit is much simpler. I want you to write a program that will just take all of the code we wrote and just repeat all of it for as many times as the player says. So, what do we need to know in order to run this loop? We need to know the number of times it should run. Therefore, we need to use the ask block and ask the user for a number. So, here's what it looks like. We do an ask for how many games they want, and then we store that number, and then we just repeat that number of times. Alternatively, you can repeat until a round's played gets to the number of games and start it at 0 and increase it by 1. This is slightly more complicated, but it comes with the upside that you know how many games you've run previously within each loop. This is the simplest way, though, the one on the right, and it is probably the one we want to use. I've used this pink block called the rest of the code to just show everything else we've written so far. So if you want to see what it actually looks like, let me see if I can undo a bunch of times all the way to the end. Okay, let me zoom out. Okay, so just this bit here. And we don't want the score keeping, just this bit, right? All of this is what we've written so far. This is setting the player choice. This is the computer choice. This is just a random block that is there so that you can see what the computer picked. This is not necessary. Then there's checking who won and adding to their points. That's the bulk of it. You just put all of it inside of this loop here, and that's it. That's what it looks like. All right. Now, the last step is to just write code that compares the 2 scores after the loop we just wrote finishes. And that's honestly the simplest thing. And here it is. It's just, if the scores are equal, the whole match was a tie. And if the player score was if it's not equal, then if the player score was higher, that means the player must have won. And if not, then the computer must have won. Again, the reason why I don't need to check that the computer score was higher here is that I know it must be higher, because it wasn't equal to, and it wasn't less than, therefore it must be greater than. So, your code should look like this right now. It should have all of this big stuff, and then it should be inside this repeat until, and then there should be this code at the bottom of it, just snapped right here. That's what it looks like right now. One last thing that you will want is this. At the start of the program, you want to set all of your things to 0. And then if you want to, after you set all the things to 0, you want to add some say blocks, like this one right here that I have written, to make it a little more user-friendly. And once you do that, you're finished. This is a working rock, paper, scissors game in Scratch. Here it is. That is all for the lesson. I'm going to demonstrate the game right now. So let's see if it still works or if I broke it. Alright, so I click on the flag. Right now, it's done all this. It set everything to 0. It's now on the how many games section right here. I'm going to type 5. No, 3. So, number of games is now 3. If you go and I look at number of games, it's now 3. There you go. Then, it's checking if the number of games is equal to the number of rounds we played. And it's not, because the number of rounds we played is 0, and the number of games is 3. So we're going to keep going. It asks me rock, paper, or scissors. I'm going to choose rock. Then after I choose rock, it's going to randomly pick the computer's choice. And I'm not going to click enter yet because it'll do a lot of stuff. I want to just show you. So it's going to pick a number from 1 through 3. If it's 1, it'll pick rock. If it's 2, it'll be paper. If it's 3, it'll change to scissors. And then it's going to show me what the computer chose. Here, the computer picked rock, which was 1. I also picked rock, so it was a tie. It checked the 2. They were both rock, so it's a tie, and everything in this else was skipped. And then we added 1 to the rounds played. And then this arrow here is signifying that this is the loop block. We come back. Our rounds played is now 1. And once it gets to 3, we're done. This is our second round. It's asking me rock, paper, scissors again. I'm going to say scissors. I hope I spelt that right. Computer chose rock. Computer wins because rock, in fact, beats scissors. And it followed the same logic as I just explained. So now the number of games played is 2. And we need 1 more for the numbers to match and for it to stop. So I'm going to take paper. The computer chose rock, which means I won. And then my score became 1. The computer score was already 1. And just then, it said that the whole game was a tie. And that is because the whole game was, in fact, a tie. We tied 1, I won 1, and then the computer won 1. That's a tie. So this works just as intended. Alright, that is the final project, and that is the end of the Codivate Intro to Block-Based Programming in Scratch course. Thank you for watching.